Hey guys, welcome to a new live stream. Let me fix that music real quick. Hey, good evening. Well, we're doing a little bit of pre-stream here because it's only 9 o'clock and we officially start at 9:15. So let me move my microphone slightly closer. It'll be in the shot, but that's okay. That's okay. I think that's okay. Something like this, and then let's adjust it. Oh, Johnny Bergdahl is here. Hey, Johnny. How are you doing? How is everyone doing? And I'm thirsty, so let's see what we have. We have a Coca-Cola Vanilla. We have a Coca-Cola Cherry. And one of my recent favorites, it's yeah, what do you call that? Fanta Lemon No Sugar. Like that one. So I'm going to go for that one to start with. Oh, questions. Let's wait for questions until we've officially started, and then we can do the questions. Oh, you saw me opening the can. Let's go back to the face. There we go. Is it in focus? Yeah, I think it is. There we go. All good, Dig Octa going strong. Nice. What's your experience so far with the Dig Octa Earth Gamer XE? Did it all go according to what you were expecting? Just note that I will be going at 2200. Hitting the bar, says Johnny Bergdahl. You hit the bars a lot, but I guess that's not a bad thing. Do I have a spot? Do I have a spot? Oh, actually, is that a spot? I don't know. Probably make it work. No, it was a plushie. I don't know what it is. It's okay. Well, Sanjay, that's an easy question. Yes, you can. You can add an infrared receiver, or like on the Dig2Go that's built in, or you have the Quinled LED ESP32 AE+, which you can also get with an built-in IR receiver, and then you can use those little remotes. Excellent Fanta choice. Thank you. Let's drink it. You didn't last week, but were you streaming then? No, I had to cry myself to sleep instead. Well, we've got we've got pink here, and we've got bluish purple here, and more pink in there, and I hope that cheers you up a little bit, Johnny. Dig Octa plus 400 pixels. One great looking tree. Cool. Oh, Philip is here. You're not late, we're just early. Can the Dig2Go be... I'm immediately diving in questions, but we'll likely get enough questions. We're going to do it slightly slower than last time because that burned me out. But can the Dig2Go be always on? The LEDs will come on, will come and go off as needed, but I want the controller to be online. Yes, it's actually designed for that use. So once you tell WLED to go off, it actually flips a switch inside of the Dig2Go, which cuts off all power to the LED strip, so you don't actually have the standby power of the LEDs either. And once you turn it on, it flips on the power. So it actually cuts off the power to the LED strip completely. So yes, you can leave it online indefinitely, and it'll use like 0.4 watts or whatever to do that. So very little power. Is it possible with 8266? Yeah, I believe so, Sanjay. You'd have to look in the knowledge base of WLED, and they should have an article about how to do that. EarthGamer had no problem setting up his Dig Octa. Easy to set up, but I got a bit confused with the standoffs because they are different from the setup video, and they are too much. There's only one that's different, but sure, I get that. Well, to show you the secret of the day, which was already kind of revealed in the thumbnail, I'll assemble a Dig Octa on stream. Although I don't actually have the new standoffs, so it'll be with the old one. We'll see. It'll work. maybe I've missed it, but what power brick and what cable is recommended for the Dig2Go? Well, any USB-C should work, but it's best, or USB-A can also work, but it's best if the power brick itself notes that it can do 5 volt, 3 amps, because that's what the Dig2Go can draw. So about 15 watts. Now, unofficially, it'll go up to 3.5 amps or something like that, but officially it's a 3 amp rated, and it's internally limited too, so it won't go any higher than 3.5 amps. And the cable, it's best to use one of those 5 amp cables, because those have more copper inside to go from your charging brick to the Dig2Go. So especially if you're using like a 2 meter or even a 3 meter cord, it's best to have as much copper in there as possible, because otherwise you're going to have voltage drop from the adapter to the Dig2Go. So any cable will do, but those 5 amp rated ones are best because those have more copper in there. But a normal cable should work fine. Just grabbed a Dig Octa Power 7 HC and a Quinled Dig Octa Brainboard 328L. Nice. Those HC variants, so the high current variants, they've been selling way faster than I would have expected. Let me adjust myself a little bit there. I didn't think... no, that's a bit too much. There. I didn't think those would go very fast, because they're kind of a top range product with being able to do 100 amps, where, most setups don't need 100 amps. But I guess people think it's cool, and it is. I mean, you do have to know how to prepare your cables for that. But other than that, it's a fine product. But yeah, I didn't think we'd go through them that quickly. But it's cool. I mean, I like it. That one was really a passion project. Designing that one and getting it to work within the constraints I had set, so thermally, etc. That took some work. But, it's fun working on the big stuff. So, yeah. More amps, more lights. Yeah, and especially in 5 volt projects, it can really matter, because the amps start to add up very quickly. So yeah, especially if you have like a Power 7 HC combined with 2 brain boards, I can imagine you needing more than 50 amps. So sure, of course. You changed Access to Everyone changed out his electrical outlet to include USB power to the Dig2Go. It actually cost me less than a high output brick. Cool. And as long as I said it, as it can do 5 volt, 3 amp, and maybe check if it doesn't get too hot if you do that for a long time, that's fine. Late Boomer here says, Bonsai, I just picked up a Quinled ESP32 developer board. Does it come with firmware uploaded, or can I upload my custom firmware? You can, all my boards, you can upload your custom firmware, whatever you want. They're all open to do with what you want, and they all include USB to serial, etc. And the Dig boards all come with firmware flashed. I don't know about the separate modules. Maybe, maybe not. It'll depend. But just plug it in and flash whatever you want. So, yeah. Sanjay says, I always watch your videos. Thank you very much. I started with WLED by watching your videos. I'm very thankful to you from India. Well, thank you for watching the videos. That's cool. Richard Campbell says, Hey Quindor, talk to us about the dangers of attaching 2 power supplies to the 7HC. Okay, well, this kind of goes for any power board, really. I have somewhat mitigated the problem, but there is something that is out of my control, and that is something called physics. Because there is a concept in electrical world, and especially with LEDs, etc., that is called thermal runaway. And that means that when something becomes warm, it'll actually transport power easier. So now imagine you have 2 lines, okay? And they're coming from 2 different power supply. And we're not even talking about the power supplies right now. I'm talking about the 2 lines. Let's say those power supplies deliver the exact same voltage. That's important to remember. Now, those 2 lines, they're never exactly the same. Even my fingers, this one might be 0.5% thicker than this one. In copper terms with cables, that means that this cable will transport more energy than this one. Just a slight off balance, although the power supplies are 100% identical, which they aren't in reality, but let's say they are. Now, the cables will start to heat up, and once the cables heat up, they'll transfer power more easily. But this one is heating faster than this one, and because it's heating faster, it's getting more power to go through it, and then it heats faster, and then it gets more power, and then it heats even faster, and then it gets even more power. So that's what they call thermal runaway. If there's an imbalance, the one that is doing the most will always be doing the most, and it'll basically skew the results by trying to push most of it through this cable instead of balancing. There is nothing that will balance it except resistance, and the resistance goes down with heat, so it'll automatically unbalance basically. Now, how do you explain then that my boards allow up to 3 input cables from the same power supply? Well, the cable thing isn't so much an issue, because if the unbalance would be really big, that's the reason why I have input fuses on the DIG Octa. Because then if one of the cables would be doing, let's say on a normal version power board would be doing 50 or 80 amps and the others would be doing 10 amps, well, the input fuse for that would blow, and that would resolve that imbalance situation basically. But now let's say you have 2 power supplies and 2 cables going into the DIG Octa, and this imbalance situation occurs because those power supplies will never have the exact same voltage or the exact same cable attached. And now suddenly one of those fuses or cables or power supplies breaks, or you pull it out of the socket or whatever, and suddenly one of those will get all the load, and depending on the quality of the power supply, it'll either explode, melt, or just turn off. If you have a good mean well, it'll just turn off because of overcurrent protection. So I've tried to mitigate the problem with having input fuses, that if a major imbalance would happen on the input cables, those input fuses will cap it anyway and keep everything safe. So even if a power supply fails or a cable fails or whatever, the fuses will keep everything safe. But the reason you can't run multiple power supplies to a single board is because you don't have exact voltage control. So you cannot say, I have a 50 amp power supply here and I have a 50 amp power supply here, so together they'll provide 100 amps. No, this one might be doing 75 amps and this one might be doing 25 amps, and there's nothing you can do about it because it's just physics. This one seemingly had a higher voltage than this one, even if it was just 0.1 volt, and now it's just delivering the bulk of the power, while this one's almost doing nothing, while this is being overloaded and this is underloaded, and there's just no way to balance them. And there are special power supplies, and they will employ techniques like having extra sense wires at the end location, and then they'll vary the voltage to always stay in line with each other. And if they sense that one is providing more than the other, they'll actually lower or raise the voltage to keep in line and in balance. But normal power supplies can't do that. So especially when things heat up and things like that, it'll imbalance automatically, and there's nothing you can do about that. As I said, in part, even from a single power supply, that's why I have the input fuses there. But from a single power supply, the voltage will always be the same, and you can't overload a single power supply because you know what it's capable of doing. And then if you have 3 wires and one is doing 20 amps, one is doing 21 amps, and one is doing 19 amps, that's not too big of a problem. So, yeah. Sorry, I went a bit on a tangent there. But I think that should explain why you can't have multiple power supplies connected to the same thing, because it'll always create an imbalance, basically. And yes, even with multiple cables, it'll be an imbalance, but it's a manageable thing, and that's why the fuses are there. The fuses aren't there on the DIG Octa, but that's because basically the power levels, they aren't there on the DIG Quad, but that's basically because the power levels there, if you use adequate size cables, even if one cable would fail, the other cable wouldn't suddenly burn down with the load. And with the DIG Octa and with the DIG Octa normal power supplies, and especially the 8C, that danger would be there if suddenly one cable got 100 amps on there instead of having it spread over two. So yeah, there's no article for that. No, but it says everywhere not to do it. Maybe I'll write an article about that at some point then, explaining why, if a lot of people are wondering. But at least it says everywhere not to do so. Indeed, says Johnny Bergdahl. Oh, no, Teal'c is more like... I'm a Stargate fan, so Teal'c is more like, indeed. Now is not a good time for an ad, YouTube, sorry. So let's scroll back. I've probably missed some questions there. It was a fun question, though. I bet more people are wondering about that, but yeah, it's about automatic imbalance you can't correct for. Another DIG Octa in the wild, working great in an enclosure in the snow, 600 pixels. Brainboard powered through PoE. That is awesome, Ziklik Zen. Did you use one of those PoE extractors to either USB or the 2-pin input? Yeah, that's why I don't build PoE into my boards, because I could build PoE into my boards, but then all the boards I produce would have to have that circuitry. And then if 10% uses that feature, adding, let's say, $8 to each board, I don't see it. Especially because you can buy the adapter for $8. So I think that's a fine solution. Maybe I'll design something at some point. Not saying I won't. But I don't think I'll design it on the controller board itself, because extractors work really easily. Johnny Bergdahl says, warning, do not buy the DIG to go if you want something that is complex to get working. Plug in the strip and it just works. Well, that's exactly the point. Is it possible to generate random effects automatically changing in WLED? I don't believe so, Sanjay. You can create playlists and do random colors and things like that, but yeah. Jaco Weiss says they are top range, but not top range price. Thank you. Can you recommend any profile for LEDs to sit in for external use? I've seen some flexible silicone ones on AliExpress. Well, we did one experiment with trying to get LED strip in one of those silicone tubes. That didn't go too well during a live stream. But other than that, I don't have too much experience with it. But I guess those would be fine for outside because they're definitely sealed. So, I don't know. Buy one and try it, I guess. Danger fireworks are fun. I like fireworks. I often do some fireworks during New Year's. Will there be a DIG Uno for analog strip? I bought some 12-volt cobs and would love to control them with WLED. Are we talking cob LED strip or cob downlights? And I am developing analog. I'm actually busy with an analog board. I guess. Do you want to see something? This isn't the official secret yet, and this won't be out for a while. But look at this. Oh, how interesting. It has all kinds of ports, and you have no clue what they do. And then it has all kinds of ports on this side too. And now it's gone. But that is for analog. That's something I'm developing, and I hope to release sometime next year. So that was the unofficial secret. That's the I can't call it a pre-stream secret because we already started streaming. So, anyway. Let's see if there's any more questions. A random effect palette. Oh, I guess. I don't know. Maybe you could suggest it in the WLED GitHub, like a random effects button, I guess. Yeah. Yep, like Johnny said, like I explained earlier, there are power supplies designed to work in parallel, but if they're not, don't use them like that. Oh god, I skipped everything. Okay. When does the fondoing start? I'm not that German guy. I'm that Dutch guy. You're misremembering. But I like watching his streams too. I only have weird drinks and stuff. Oh, okay, yeah, Zip Click Zen. He has an extractor to USB-C, working great as designed. Nice. Wait, Den Bell says, I have a power supply 5 volt, but when the fan do not turn lights do not turn on, I change the power supply and works fine. When the fan turn, could it be the power supply defected? I'm going to answer this with a yes. I think, yes. Sorry, I don't quite get what you mean, but it could be the power supply defective or the fan is creating an issue. Not sure. Are there any plans to have a nice analog control for these nice and fancy cob LEDs that are out there now? Well, yes, actually, and I've been working to design that. And we've seen prototypes on the stream before. We even soldiered one during the stream, like this one. This is the old prototype, actually. I don't know where the new one is. But there's issues with it. And I'm not sure I'm going to be able to resolve those issues because of just how constant current works and how that's very different than I thought it would, including dimming. And basically, there's no way to do constant current with PWM input without the PWM coming out of the output, which was what I don't want. And I'm kind of stuck in that story. So I designed a whole lot. It actually works as designed, but I don't like what it does. Does it make sense? Yeah, it works exactly as it should, but I don't like how that is. So I don't know where to go from. I've kind of halted that project for now, and I'm not sure where to go with that. So maybe at some point, but right now there's no CC stuff. Jose Otero says, I got a power analyzer to check my power supply. I have around 850 LEDs and it's telling me that I'm using just 4.5 amps. Is that okay for 850 lights? No. Well, yes and no. If you are okay with how the lights are looking, then it's okay. But if we're talking about how much power it should be using, well, first of all, that depends on the effect you're displaying. But if we're talking like a 50% white value, with which we often calculate our expected power usage, then you're a few orders low. So you should be seeing like 15 amps instead of 4.5 amps. And that is 100% the reason voltage drop. So you do not have enough injection points. Thus the voltage will drop and then it won't ask for more amps, basically. So you're very low there. Do you think any future products might be able to support 800 pixels at 40 frames per second? What do you mean, Ryan? I think the current products would actually do that, as well as any other product out there. Because well, let's take a little web browser real quick. Web browser. One moment. I have to prepare the web browser. Let's go to here. And let's make this slightly bigger. And then I should be able to go here. Yes. No, it's too big. There we go. So if you go to my website and go to digitally addressable LEDs and then scroll down to the articles, there is the what is the max amount of addressable LEDs per controller. And the reason I state this is 500 to 600 is to have a little bit of room there, etc. And it's easy to remember to just have like 600 LEDs per channel. But there's actually a technical bit behind that, and that is how often. So the WS2811 or 12 or whatever protocol is a fixed rate protocol. So if you have, well, it says it right here. If you have 300 LEDs, you can update those with 111 frames per second. But if you have 600 LEDs, you can update those with 55 frames per second. And then if you have 1,000 LEDs, you can update those with 33 frames per second. And that's where the limitation comes from. The data rate is always the same, but as you add more LEDs, each individual LED will be getting slower updates because the data doesn't go any faster. And if we calculate that for the 42 FPS that WLED runs on normally, that is 793.6 LEDs. So if we extrapolate that slightly to 40 FPS, you could, in theory, run 800 LEDs from a single data port. But I don't like that because you need to allow for a little bit of overhead and variation in timing and processing of the ESP32 and things like that. So that's why I generally say, no, don't do that. Just put 600 LEDs on a single port. Then you'll have a little bit of overhead. And there's a second reason for that. If you have RGBW LEDs, there's not 3 channels per LED, but 4. And thus, each LED will take longer to update, and you can have less total LEDs, as you can see here. So that's the reason for that 800 limit. Now, there are other protocols like APA 102 and protocols like that, which use a data wire and a clock wire. And those protocols, WS2812B runs at 800 kilohertz. And those you can run at like 2 megahertz, 4 megahertz, 10 megahertz. And then your data rate will scale with that automatically, and thus you can create much longer LED strips without the frame rate dipping below what you want it to be. But those strips have their own issues with having that high speed signals, which then generate their own issues basically over distance. So generally we stick with the clockless LED strips, so just having a data pin instead of having data and clock there, because that's just easiest to work with. So hopefully that explains why that 800 limit is there, and how you can circumvent that by using multiple data ports. And then there are other variants out there, but those are generally a bit harder to use. Tech Nickley Christmas says, bought 3 Octa and love it. Super easy. Thank you for providing a sound, well-built device I can use for my business. One question. What external 12-volt power supply would you recommend? So let's go back here real quick. I think it's this one. No, it's this one. Yeah. If we go to the digitally addressable LED section and then go to the DIG Octa system, there is an article that says power board power supply recommendations. And there, one power board, one power supply, there it is again. Never connect more than one power supply to one power board. It couldn't be more clear than that. But there it says for normal up to 50 amps, we can do 5 volt, 12 volt, and 24 volt. And we have without a fan, 5 volt, 12 volt, and 24 volt. And then high current boards. So if you have an HC board, I also have with a fan and without a fan. But especially like these guys, this is good. This is a massive amount of power. A 110 volt circuit cannot provide this. 30 volt only. So that's insane. But yeah. So I have an article which goes over the power supplies that I recommend for the DIG Octa power boards. Right? and it's in the Dig Octa power board section. Okay. Oh, I think we're at the part where I show the secret board. Secret! No, I skipped past it. Damn it. Oh, black box. Woohoo! If it's from you, then shut up and take my money. Thanks for the confidence there, Jonathan. We saw nothing. The black box secret. Wow. He is the one Dutch guy who's not watching TV. I was going to ask what's on TV, but I think it has something to do with soccer, and I couldn't be interested less. So... let's see here. Grab Mihai Alexandru, hope I didn't butcher that, says, I want to use... Oh, is my microphone a bit hot or is it okay? Maybe if I'm up too close. Want to use 40 meter of LED strip, 12 volt, 60 LEDs per meter. Oh, you will want to stay for the last part of this stream. But anyway, can I use 2 pieces of dig quad? 20 meter on the first dig quad and 20 meter on the second dig quad. Can I do one effect over the 2 pieces of the dig quad? Yes, you can. I'm actually going to refer to the Dig Octa section again. Dig Octa system. No, not getting started. The system usage examples in the Dig Octa section, and I need to rename that article because it's a dumb name. But in WLED, you can do local effects. So if you have a single board, you can do remote sync. So have 2 boards and they'll do exactly the same. Or you can do something I've called WLED remote continuous. And if we look here, we can see that this board is sending out LED data. So we have a single channel, the first channel that has 300 local LEDs. And then we have a second channel that has 300 LEDs too. But it's DDP RGB network. And it sends it to this IP address. And then that IP address has to be a WLED board again, where you configure those 300 LEDs. And board A will send the data to board B over the network. And it'll act like it's a strip connected to the first ESP32, but then, sends its data over the network. And generally, if there's not too much lag, etc., especially using Ethernet, that works pretty well. So yes, you can run 2 WLED boards and have them act as one. Just one thing to keep in mind is that the limitations that are there, so like 2,000 to 2,500 LEDs in total for a single ESP32, those still remain because that first ESP32 has to do all those LED calculations, right? That's how we otherwise scale, and that's also in this article. If you want to scale further than that, we want to use remote data where something else is generating the effects as a whole and then sending it to multiple controllers. And those multiple controllers don't know what the others are doing, but that means the central unit has a lot more processing power to, direct the whole show. And there's multiple ways to do that in hybrid mode using SD card or using Ethernet, etc. So, yes, you can do that, but there are limits. And if we're talking about 40 meters of 60 LEDs per meter, let me do a very quick calculation for that. So that's 40 times 60. That's 2,400 LEDs. So that would kind of be at the edge or over it. But since they're WS2811s, we have to divide that by 3. And that's 800 addressable zones, as I call it. And that's well within the limits. So you can easily sync that over multiple boards. Hope that explains that question. BitLooney and Winter Garden need to do a collab. Okay. Hope they don't get fondue on the marble machine. Yeah. Sanjay, I mostly work on the hardware, not on the software side of things. So I'm the wrong person to ask for software features right now. Let's see where I am, because I'm kind of... Johnny Bergdahl asks, have you tried out using high-power server PSUs? They can be connected in parallel and comes in like 12 volt and 1600 watts. I've used them, but then for the intended application, as in running a server. Other than that, I've heard good things about that and that they're high quality. They'll make noise, but other than that, they should be fine. And as long as you connect it with an appropriate amount of cables to the power boards, that should be fine. The clue there is to make sure that all the cables are the exact same length, because otherwise power won't distribute evenly over the cables, because a longer cable will have more resistance than a shorter cable, and thus the shorter cable will do more than the longer cable. Basically what we talked about earlier. Steckers asks, can you point me to a site where I can buy a case for your digs? Well, there's the international or the worldwide store has a case available. It's an acrylic plate case. Other than that, most people either build them into a box or they use a 3D printed housing or something like that. So a little project box or something, that would probably be best. Yeah, I don't, Philip. Yeah, don't parallel a power supply that's not designed to be paralleled. And server chassis often have the mechanics to run to power supply in the server chassis, not in the power supply itself. So if you then run two power supplies that are not designed to run in parallel without extra electronics regulating that, that's stupid. Let's see where we are. So, Grat Mihai Alexandru, how do you connect to 40 meters of LED strip, 12 volt power? Can I bring sensors to board and say WLED to start just a segment? Can you show how? There is multiple tutorials online on how to do that, and I have wiring diagrams, for instance, for all my boards and things like that. So I'd suggest starting there. And then if you design a setup of how you think you should do it, come to the Discord server, we'll look over it with you. And then we'll give you tips and tricks on, what's good and what needs improving and how we do it differently, etc. We do not do the design work for you. The idea is that you do it yourself and we'll check your work, but we're not a design firm. We do paid consultancy or things like that. So this is DIY. You have to do the work. If you don't want to do the work or do the learning to do the work, you might have to hire someone. Whoa, Danny B. Injection points versus bigger power supply, says Mark Preston. That's an invalid question. Because a single injection point... Well, we'll go back to the articles. Right? We go back to the digitally addressable LED section, and then it says, how much can a single injection point handle? And if we scroll down a little bit, a single injection point will basically do about 4 amps, even with 16 gauge wire connected to it. And then if we add an injection point, it'll do 8 amps. So it doesn't matter if your power supply can do 100 amps. A single injection point won't take in more than 4. So it's not a question of injection points versus power supply, because if you just have one injection point, like the 850 LEDs we saw the question earlier, it just won't use more. So, yeah. Injections versus power supply, no. Let's see here. Is it possible to destroy the A0 input with a mic that's so the WLED is no sound signal anymore, the rest is working? Thought the mic... Oh, don't know. Are you sure you set the pin correctly to GPIO 36 from head, I believe? Yeah, I don't know how to verify that otherwise. Dutch Taurus asks, do you have any indication that there will be RGB LEDs with better CRI in the near future? No. But stick around till the end secret. You'll want to know. No soccer, only football. Well, couldn't even care less. Can you use a separate power supply for power injection, not directly wired to the octa, whatever? Yes, you can use, in digitally addressable LED setups, you can use multiple power supplies as long as you make sure of two things. One, ground is always connected everywhere, and thus also between the two power supplies. Okay? Two, positives may never meet. So at some point in your strip, let's say you have your controller, where am I? Here. And then you have like 10 meters of LED strip, and you're like, this power wire is becoming too long and I don't want to mess with buck converters, whatever. You keep the ground going, you keep the data wire going, and you cut the positive wire. And then you have a different power supply on this side, and that connects ground and positive also, and maybe have a ground wire between those power supplies just to be sure, and then you can continue your LED strip. So two rules: always ground, never positive connected, and then you can do that. Make sure to use appropriate fuses and things like that. I'm too far behind. I'm going to scroll down. Sorry if I missed your question. Your question was external IPS power supply? What's an IPS power supply? UPS? IPS? What? Good evening. This is my first time joining a stream from you. Hey there, Chris. Welcome. 0-2. Is that the score for our not soccer but football? What? Are particular pins on the ESP32 not able to be used for WLED purposes other than the ones for SPI flash on board? Absolutely, Moo. There is input-only pins. There is bootstrapping pins. There is pins which will do funky stuff during boot but not later on. There are pins that need a pull-down or a pull-up, which you can change after booting but not before booting. And then there are dedicated pins for flash and for Ethernet, and there are pins that work better or worse for SPI or for I2C, and it seems like the ESP32 is easy to use, but the pinout for the Dig Octa took me quite a while to design this pinout and have everything working at the same time correctly. So, yes. Read lots of articles, white papers, data sheets, forums. You'll get there, but it takes a lot to figure it all out. And then, of course, do testing. Lots of testing. He hooked the PSUs in serial. What? Well, I guess he needed a higher voltage, but no, don't do that. About to deploy a DOS running ESP pixel stick with a 7HC power board running a matrix of 2400 pixels, running 8 channels of 300 WS2811 pixels each. Chances of success? Pretty good, I'd say. There are some issues, but I believe they've solved them now in newest versions, of having 8 RMT channels on the ESP32. and that they have some weird initialization error. So if it's not working for you with 8 channels, you could try lowering it to 4 and then having 600 per channel. But in my testing, having 8 channels nowadays should work fine. So yeah, let us know how that goes on the Discord server. That'd be interesting. And post some pictures in LED Talk or in the showroom or something like that. How do you not connect positives since the data line is continuous? Well, Rob, the data line is also a positive line. So that's why you need to have ground connected, because you can look at ground as being 0, and then the data line will pulse up and down between 0 and 3.3 volts, or sorry, 5 volts actually, because there's level shifters and such. And that's why the ground needs to be the same, because if you have disconnected grounds, this ground might be at 0.2 volt and this ground might be at 1.1 volt. Yes, ground isn't actually 0. And then the signal between that two is based on this ground, but it's now on this ground, and what the hell's going on? Signal's broken. But if you connect the grounds, everyone's 0 is the same, whatever voltage it might be at that point. And so 0 and 1 is clear, and we don't need that positive voltage. That's just energy, basically. And that's fine if that's from a different power supply. Hope that made sense. Baited by the master. Paul Hibbert? What? Does Paul Hibbert often bait? I generally don't watch his videos too much because they're a bit too high energy for me and some other things. But I mean, he makes nice content, but you know. Scotty. Whoa, you just blew my brain with all the nerdy electronical alphabet soup jargon. But I love it. Always enjoy your streams. Thanks for all you do, Quindor. Thank you for being here. Hey, I mean, I often say this like on Reddit or in other places. I'm just some random guy on the internet too, like you guys are. I just happen to sit in front of the camera and talk about a lot of stuff, but yeah. Oh, well, John O'Brien kind of just mentioned that. Having fewer channels with more pixels is, it's not so much less resource intensive, but because of the internal structuring of the RMT devices on the ESP32, there were some issues with initializing more and more. And so having fewer used to be better, but I don't know if that still applies. So, yeah. Is there a way to sync a second WLED board using Hyper HDR? I have no idea. Paul Hibbert is a bit too much. That's my opinion. I mean, I think he makes good videos. It's just, you know, I think it speaks to a different audience. That's fine. I mean, there's place for everyone, so... Sorry, that's not the thing I wanted to say. There is room for everyone. So, yeah. Rob Keane says, yeah, I think so. I'm actually running a length with one power supply dividing the controller and first injection and a second power supply at the other end. Both 5 volt and connecting together. So, there's a reason that works. And that's actually the reason I already alluded to earlier, and that is, again, resistance. So, before I mentioned, if you have 2 power supplies, and one has just a slightly thicker copper wire or 0.1 higher voltage, etc., if you hook them up together, that will create issues, and they can overheat and overload and be completely unbalanced and create a dangerous situation. Now, the reason why we power inject is because of voltage loss. And the reason of voltage loss is because of resistance. So if there's now 10 meters of LED strip between these two power supplies, the chances that they're going to be the exact same voltage and that this power supply is going to override the other power supply are actually very low. And I keep recommending the general practice to not do it, but I have done tests with it, and running multiple power supplies, if they're spaced far enough apart with enough resistance in between, is actually not too big of an issue, especially if you have all the lines fused to the expected current and that the fuse will blow if there's too much current going through it. I'd still not recommend it, because if unknowing people will build setups like that, and they might just put them close together and like, hey, now I've doubled the power, that will possibly create fires. But if there is enough resistance in between, if this one is feeding 12 volt and this one is feeding 12 volt, and there's 10 meters of LED strip in between there, well, in the middle, it'll be like 10.5 volt or 11 volt. And only when there's almost nothing is turned on, so there's very little current draw, will those voltages meet and start to influence each other. And there is still the thing of like one power supply back feeding into another power supply, which is also a dangerous thing, because this one might be 2.3 volts, 12.3 volts, and this one might be 12.1 volts. And that would mean that effectively this power supply is forcing power into the other power supply. But that will only happen if there's zero load. And in theory of digital LEDs, there will always be some load, but then how much is enough? 50 LEDs, 100 LEDs, 500 LEDs, or strip material in between there. And so, in theory, it's still a dangerous, uncontrollable situation because of overload issues and backfeeding issues and things like that. So, that's why we officially don't recommend it, but in practice, if you do it anyway, it will work. But it's just dangerous. So, keep that in mind. I mean, overloading of the wires and things like that, you can protect with fuses. But backfeeding, if your power supply is of crappy quality to begin with, I don't know how it's going to handle that. I mean, yeah. So Rob, I get that it works. Just be very careful with that. Philip, yeah, but you are the random guy that enables a lot of other random guys, girls, whatever, to have blinky things in their lives and become addicts. Well, thank you very much, Philip, for the €5. That's very much appreciated. Grat Mihai asks, can you explain short what is the advantage, disadvantage for a long segment of LED strip to use more dig quad or dig octa? The amount of LED strip you can string behind those is exactly the same. The dig octa is just a bit more flexible, that you have more ports. So if you wanted to run 2 LED strips of 2 meters and 600 LEDs each, there's not too much of a difference there. But if you wanted to run 16 props of 100 LEDs each and 2 per channel, because that makes cabling easier, well, then with a dig octa you have 8 channels. And if you also wanted then Ethernet and SD card support, well, the dig octa is your go-to in that sense. So there's differences in what the boards can do for you, but if you're just running a single line, it won't matter too much. Maybe you want to use 12 gauge wire for power injection. Again, that's a dig octa feature, but it won't fit on a dig quad. Maybe you want to run multiple brain boards, multiple power boards, it depends on the features you're looking for, but just running a single long segment, it won't matter too much. There is a place for everyone. They're just not all there yet. Oh, Brian says, just bought my first quad. Thanks for creating it. Oh, thank you for buying it. That's very much appreciated. Sure, you think there'd be a diode there, but then you bought a $5 6,000 amp power supply in China. I'm not going to say that diode's there or not. I mean, Meanwell's, sure, I've tested that. It'll work. It'll be okay, I think, maybe. But anything else, I'm not going to say it's fine to do that because it potentially might not be, you know. I can explain why, and then you can make the choice of doing that or not, but, yeah. What is your favorite go-to LED variant for strips? Is it time? We're only 1 hour in, but we need some time to build it and prepare it. I used to have a favorite LED strip. Okay, I think it's, do I have one over here? Yeah, I have one over here. Hold on, let me get it. Philip knows it. Philip knows it. So, my favorite LED strip for a long time now has been this stuff. Oh, okay. Okay, yeah. So this is BTF lighting, right? And this is WS2811 LED strip, so 12 volt. It says it right here, 12 volt. But with 96 LEDs per meter. And it's the bright variety, which is often denoted with this H, I believe. Rob Keane is loving this stream. He's learning a lot. Cool. So this is that LED strip. I often get it in IP65, and it has discolored. Has it discolored? I don't know. No, I guess it's supposed to be like that. I don't know. We'll see. You know, it has 96 LEDs per meter, which is quite a lot. And then it has the external WS2811 chip. Now, why is that external chip important? That is because if you get a WS2812B or a WS2815 or whatever, those all have those integrated controller chips. That means that whatever strip you're getting, that LED chip or LED package will be the same. So it doesn't matter which vendor you buy it from, etc. If they're using official WS2812B or LEDs or 2815 or whatever, those LEDs will always be the same. But since this is an external chip, these LED packages over here can be different. And they have a normal variety, and this is the bright variety, and they use different LED packages on here of higher quality. So in my experience, it gives off a bit more light, but especially it's a lot more vibrant than normal LEDs or normal addressable LEDs. So the reds and the blues and the greens are much more punchy and deeper and have more color in them, I almost want to say. So, yeah, I just, like the look of that better. So that's why I've always liked this strip, and it's 12 volt. You can run a 5 meter strip with a single injection, no problem. Or you can run 10 meters of the stuff with just front and end connection. And it looks really, really good in my opinion. But this week, I received something that has changed the game. Two somethings actually that have changed the game. One has changed the game right now, and I'll be making a video about it soon, I hope. Hold on. Let me try and get this in the bog. Oh, Johnny has to go. See you later, Johnny. Why is there some weird echo going on? Not sure why that is. So, this stuff is still great. If you want, traditional LED strip, this is really great LED strip. And because it's 96 LEDs per meter, the fact that it is per 3 addressable is less of an issue because it still has 32 addressable zones. So it's basically the same as a 30 LEDs per meter LED strip, but then having 3 LEDs in that spot. So things blend together nicely. Let's do a quick question. In the meantime, Randy asks, does it matter where the data booster is placed on a long power feed? Beginning of the feed near the power or at the near of the end feed closer to the LED connection? It depends what you're using the data booster for. Is it to change the resistor value? Then it needs to go right at the exit of the controller to change the resistor value that's transported for the rest of the way. Is it to inject power? Then you need to do it at the spot where you need to inject power, so like after 5 meters or something like that. Or if it's to bridge a gap, you do it at the end of the LED strip, then put the data booster, and then bridge the gap. What did I do? Oh, he should drunk text you? Okay. Anyway, let's get back to what I wanted to show you guys. One of the things I wanted to show you guys today, and that is in this bag. And it says it right here. It says fob cob strip. What? Okay, well, fob and cob kind of denotes the manufacturing technique. We're not going to go into that right now. But it has 720 LEDs per meter. What? It's 5 meters. It's DC 24 volt. Full color RGB dream color, so it's addressable. Well, it's not RA CRI 90 because it's RGB. What? Do you guys remember that ultimate LED strip I had like a year or 1.5 years ago? That had 332 addressable LEDs, also in a cob LED strip. Now, this isn't that, because that was 5 volt, and this is 24 volt. And having higher voltage means that they need to spread out those volts over multiple LEDs, just like the 12 volt strip just now was per 3 LEDs addressable. And, well, this is a cob LED strip, and what that means is that it has this cob material on here. You can see that like that. Let me zoom it in more. Whoa. Nope. Well, close enough, I guess. So, and being 24 volt, it means it has larger sections. So between this point and this point means it is 1 pixel or 1 addressable zone, as you could call it. And this one can be red, green, or blue. And then this one can be red, green, or blue. And then this one can be red, green, or blue. And then this one can be red, green, or blue. So it has relatively big zones. But actually, let me compare that. Yeah, okay, the zones are bigger than for the 12 volt strip, because here we have 3 LEDs which will do the same, and here we have this zone which will do the same, and this is definitely smaller. So, but on the other hand, it's 24 volts instead of 12 volts, so it only makes it easier to use. I think I'm getting some kind of weird ringing in my headphones. Is that something you guys are hearing on the stream too? Okay. Oh, sounds fine here. Okay, then it's probably literally in my headphones, so I'll just try and move it. It's Johnny Drunk calling you. Right, so yeah, they have a big 24 volt strip, and then they have data in, data out, and ground over here. And then the little addressable chip is over here. I believe it's a GS whatever variant. I don't think it's an actual WS2811. But it doesn't matter too much. It's WS2811 compatible. And then it has some resistors and capacitors, and this is a capacitor. These are all resistors. And, you know, it goes on like that. But since it's a cob LED strip, per meter it has 720 LEDs. That I'm still boggled by those numbers, but that means that one of these sections will have, I don't know, 12, 15, but we'll see that in a minute. And the advantage of it being cob LED strip is that this will basically blend together, because this material is a diffuser in itself. So normally you have the normal LED strip, and you have to put that in a aluminium channel and then a diffuser on top of that. But this basically has that built in, like that 332 LEDs per meter strip. Now let's stop keeping you in suspense. Let's take a dig quad. I don't feel like building a dig octa right now. We'll do it with a quad. It's fine. And let's hook up power. So let me prepare some wires here. And this is one of the two secrets I want to show you, because there's another one. So we're doing the secret stream today. Let me make sure I put these wires in the correct spot. Remember, these are 24 volt LED strip. Is that minus? Yes. So, because of that, wiring requirements automatically become a whole lot less. Okay, let me zoom that out a little bit. I think I turned autofocus on, not sure. Let there be light. Keep some for Christmas. No. Let's just reveal all the secrets. Right? Oh, in case you're wondering, I had a question earlier this week. Like, hey, I see you using these fork terminals on your boards, but how do I know what fork terminal I need? And I was like, damn. Oh, well, let me put this one in here. This is actually too big slightly. I was like, damn, that's actually a really good question. So I sat down, little intermezzo, hold on. Let's go back to the digitally addressable LED section on the website again. And I sat down and I wrote an article called "What Size Fork Ring Crimps Do I Need for Quinled Dig or Meanwhile PSUs?" And, well, I wrote an article, what you need. There's even a quick link there if you can't be bothered to read it. But basically, these are the forks, you know, and they come in different sizes. But then, how do you know what those numbers mean? Well, I explain what the numbers mean, and you need a tool for that, etc. But for the Quinled boards, you need SV 5.5 minus 4. So 5.5 means it can accept 12 to 10 gauge cable, or 3.3 millimeters to 5 millimeters. If you have a smaller cable, don't get an SV 5.5, but an SV 4 or 3.5 or 3. And the minus 4 means that it's for an M4 screw. And the bolts in my board are M4 screws. And on the Dig Octa HC are M5, so you get an SV 5.5 minus 5. Right? So I hope that explains better for people wondering, how do you get these fork terminals on there? Because those are the best to use for these boards. There is now an article for that. Right. So we have power connected. We have some fuses. Okay. Let's hook up a wire. Do I have one here? I should have one here. It's connected in a block. Okay, let's disconnect this block. Can I do off this one? Nope. One moment. What board is that? This is a Dig Quad. So if you go to my website and you go to digitally addressable LEDs, and then you go to Dig Quad, that's this board. Check your stats. Uh-oh. Am I dropping frames? I did drop frames. Damn. Not sure why though. I'm doing it wrong. No, I need to pay attention. I need to put positive in positive. There we go. Yeah, we had a sudden lag spike, but it's gone now. I don't know what would have caused it though, and I don't have the resources right now to investigate that. So, we have a positive wire, we have a data wire, and we have a ground wire. And I see these are all flipped to 33R mode, so I'm going to flip those back for now. Because we're not going to attach a whole lot of cable, and it's separated cable anyway. And, well, we'll just connect this like that. And let's put the ESP32 board on there. It's important to align that correctly and have the USB port on this side. There we go. Let's figure out where the power wire is. Is it this one? Yes. Uh-oh. Do you guys also build towers on your desk, and then if you move something, it all come crumbling down? Let's see if there was any questions. Yeah, there was some lag. Okay. What desk document camera are you using? That place somewhere on the side where your just focus raises my interest. I'm using a Panasonic G7 for this top cam over there, with a 10x zoom lens, so I can adjust the zoom. And I just have a external focus wire connected, so I can well, manually force it to refocus. But I changed the settings recently, I think, so it might be on autofocus slightly. Anyway, yeah. So let's leave it on the strip, or on the roll for now. We'll unroll it in a minute. I guess we put the controller on the screen too, huh? Something like that. Okay. I think I pre-configured this ESP32, so that's going to be boring, but we'll see. We'll see. I think everything's right. Yeah, let's do it. Oh, it's a bit bright. Hold on, let me look up the IP address of this ESP32. Okay, and let me go into this mode. There. So that's a bit bright, so let's lower that brightness. Yep, we got the right one. That's good. And so configuration-wise, this is 5 meters of, well, 720 LEDs per meter, 24 volt addressable cob LED strip. But with the zones we looked at earlier, there is 100 addressable zones. So if you look in LED preferences, you'll see that I have 100 LEDs configured, right? And I don't have the brightness limiter configured. So, you know, we can do single colors and things like that. And let me actually try and show you the strip like this too. And I'll go back to the big view. It's still... Oh, I need to change this camera a little bit. There, now you can see the individual LEDs. And if I do a simple effect, let's see here, Chase for instance, or Chase 2. Yeah, like this, you can see... Oh, okay, not that way. Let's see what I need to do. No, I want to have one of the blocks light up, but I need to find which one. What would be a good effect for that? Saw? No. Spots. I guess we'll have to wait until it lights up the right spot. Oh, theater. That's a good one. Thank you. Let's slow it down. Right, so let's start with the downside. This is 5 meters, but the 5 meters only has 100 addressable zones. So with 30 LEDs per meter of traditional LED strip, you have 150 addressable zones. And with 60 LEDs per meter with 5-volt LED strip, you have 300 addressable zones. And even with that 12-volt WS2811 bright I showed you earlier, that has 3 per 3 addressable, but it still had 32 zones, and this only had, or per meter, and this only has 100 per 5 meters. So that's like 20 per zone, or 20 per meter. So it's the lowest addressable amount. But what you get for that is really, really bright LEDs. And let me show you that. So this is full brightness. I mean, even with only these few lit up, my face. Let me show you on solid. And my studio is quite bright, and these are still rolled up. So, yeah, let's tone that down again. And I don't know. It really looks like neon LED strip. That's how good and vibrant the colors look. So although you only have 100 zones, if you do single addressable effects like theater, for instance, yes, it'll look choppy. Well, I can make it go faster, then it looks less choppy. But it'll look choppy because the definition or the resolution of this LED strip isn't that high. But if you do blended things like where is it, for instance, palette, for instance, which I like, now you can already see, that's why I kept it on the roll for now, that actually the blended effect works really well. And now if you look here, this is 3 zones. Can you tell which zone is doing what? I can't. I can't even in real life. It's just one blended mess of things. And let's go to another effect. Pacifica, that is traditionally very dim. So let's just give it full power. No, that's too much. Okay, let's give it like that. Even this, which has spots that move over the LED strip, but they are blended, looks great. Right? So that's a good question, Dutch Towers. Where would you use this LED strip? I'd use it for a lot of places, really. It really depends what you're looking for. If you're looking for something like that, so it's short, close by, and you want to have good definition, this isn't it. Then the 5 meter cob LED strip we looked at before with 332 addressable zones per meter, that is a lot better, and that is 144 addressable zones or LEDs per meter. But if, for instance, you wanted to go all around your room, or you wanted to have a 12 or 10 or 15 or 20 meter LED strip, or anything bigger than 5 meters, really, this will make your life a whole lot easier, because it's 24 volt, and it gets so bright, and the colors are amazing. Compared to normal LED strip, the colors look dull. And these look so vibrant, and I dimmed down the camera a lot. It's just, it's hard to describe the difference, basically. Oh. let me. I think that's okay. Slightly less. There we go. Did I miss something? Oh, Invoice says first year doing Christmas show. 1 dig octa power 7, 5 volts, and 2 dig octa. Or probably brainboards then. I want to expand. Can I stack 1 more dig octa power 7 for 12 volt by not connecting Q power post? Greetings from... Oh, groetjes from Curaçao. Actually, Inboy, you can connect another power board. And you can stack another power board. That's no problem. But you can even connect Q power post if you want to, and the bus system will automatically run at the highest voltage. So you can have a 5 volt, 12 volt, or 24 volt power board in the same stack without a problem, and connect it to the same brain boards, etc. So you can mix and match whatever you need. You can, of course, also do so without connecting the Q power post, but there is a additional standoff with each brain board, or actually you get two, to connect all the power boards together, and voltages doesn't matter. That's all protected and regulated. So, got to go. See you later, Andy. Earth Gamer, I have ordered some different versions of this. Because I'm so excited by this. This has instantly become my go-to recommended. I still want to do more testing, but then this is so good. It's just hard to describe. And I'm going to turn it off real quick and roll it off of the roll. And I'll also try and show you on the primary camera. Because A, it's a lot easier to use than regular LED strip because it's 24 volt. Let me just show you this with the face cam. Because it's 24 volt, you can run almost 10 meters of it without power injections, just a single edge connection. Of course, that won't work for 100% white, but anything other than that will work pretty well, even with a single power injection. So you can run 10 meters of the stuff, no problem. And I'm just gonna, I'm just gonna put it around myself real quick. Because then I can show it on the main camera how good this stuff looks. That's nice and warm. Okay, let's go. There we go. And that's half brightness. So let's go full brightness. Oh, look at that. That's really bright. And as you can see, with an effect like this, if you'd have this stretched out in your room or in a bar or whatever. Oh wow, it's getting warm around my neck now. Hold on. I think the LED fumes are getting to me. But as you can see, I mean, yes, there is bigger zones because you don't have as many addressable LEDs. But even if I turn this down so you can see those really well, and I hold it up like this, can you see an individual zone? I can't. And that is because of the cob material. If these were, like on the 12 volt strip I showed earlier, 3 individual LEDs, well, you'd see those 3 individual LEDs very clearly, right? Even blended effects and things like that, they would still be that single LED, and you'd have to work with a diffuser and things like that and get it the right distance for it to blend together. But this stuff is blended together from itself, so you don't have to worry about any of that. If you just put this, I would still recommend an aluminium profile, but it doesn't have to have a cover, or you could get a clear one, or you could still get a diffusing one. But the biggest difference is that it is cob material and not individual LEDs you're looking at. And sure, I can show you the individual LEDs if I get this off there. I mean, they're there, if I adjust my camera a lot, nope, other way. Oh, that's a bit too much. Let's put it on solid. And let's do red, for instance. No, let's do... No, that's not a single LED. Jesus. Green? And then we're getting some PWM noise. Yeah, it's hard for me to even show... Okay, this kind of works, right? So let's zoom in. So here you can see those individual LEDs kind of. Okay, if you look at it like that. You can see those individual LEDs, and I'll try and highlight a segment. So this is a segment. And you can see there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I don't know, about 14 LEDs per segment. And, well, as you can see, if I keep it like this, if I change it to red, and then change it to green, no, it fades to black. Hold on. Oh, no, I can't do that. Wait, okay. If I do a dual color, can you see two? Yeah, and then you can see that there's actually two LEDs lighting up instead of one. Right? But because this material blends automatically, it basically looks like neon to my eyes. It's very nice. It's excellent. I have these listed in my video description if someone is looking for them. So, 1 5-meter strip, that's kind of a downside, but that will go down over time as more people adopt it and it gets used. I believe is about $50. So that isn't cheap, but you also don't have to do any power injection or things like that if you don't want to do anything crazy. If you do want to run right, I would advise injecting every 5 meters. But otherwise, for generic effects, you're fine for 10 meters with a single injection. And if you want to go a little bit more crazy, I do front and back for 10 meters. But it's amazing. I'm really, really surprised by it. Because even effects like this, sure, if you look at it directly like this, you can see somewhat the sections, I guess. But if this is stretched out over 10 meters or something like that, I think it will look absolutely excellent. So let's do this with some other colors. Yeah, it's just, I love it. So that's, I guess, one of the secrets of today. This new type of LED strip. And I will be making a video about it. But, well, you've seen it here first. Or maybe on Discord if you were there. I really, really like this stuff. Yeah, it's likely 12. Maybe I miscounted there, Rob. But I haven't actually counted. I guess I can count them. Let's see. 1, 2, 3, 4, 5, 6, 8, 9, 10, 11. Yeah, it's 12. Yep. No, yeah, I would put them in a channel because if you run these at maximum, they will get warm. So currently we're drawing 9 watts. That's not a lot. So let's put it to full power. And let's do the default colors, and let's do rainbow, rainbow, rainbow. There we go. Bam. Oh! Okay. It is using 41.7 watts from the socket. So let's say this is using 40 watts. That is a lot for LED strip. For the rainbow pattern, you can use my comparison charts. I haven't added these yet. I will do so in the future. But yeah, you can use the comparison charts to look at the wattages. But basically, especially because cob LEDs are generally more efficient than the bigger LEDs, this is outputting a lot of lights. Ah, Paulson, go full white. Sure, let's go solid and then white. Ugh. It's drawing 104 watts. And I've already hooked it up with an extra injection wire, and then it'll draw 115 watts. Because there's a slight amount of voltage drop there, but I doubt that would be visible. So, yeah. I don't know, man. Yeah, it's amazing. It just looks so... It's hard to show you on camera how vibrant and nicely diffused this looks, basically. And that's the big difference with that kind of stuff. That's... You see the individual LED, and that's okay. That's what it's made for. But this is just so different. And I think this is more of the effect a lot of people are looking for versus seeing the individual LED, and then they have to mess with diffusers and LEDs per meter count and the height of the diffuser and things like that. With this stuff, you don't have to worry about it anymore. There are no hotspots. Yeah, it basically uses the same power, Philip, that's correct. But then it's 24 volt instead of 12 volt, so power injection will still be easier, given that the amount of copper in there would be the same. I don't know if it is. I've ordered more of these so I can string more of them together and see how that works in reality, because I like to do real world testing. But yeah, it's awesome. So light output Alvaro, I'd say, is slightly higher, and I'd say this is one of the brightest strips I've seen in a while, because it uses about the same power as the 96 LEDs per meter WS2811 Bright, but in theory these cob LEDs are more efficient. So less is transformed into heat and more is transformed into light. So, yeah. 240 per meter times 3. Yeah. Yeah, that's also what the packaging says. It says 720 LEDs per meter. So if you divide that by red, green, and blue, you get those 240. So yeah, that's true. How do these chips come next to the top of the strip? Because if you do not want to use a diffuser, you probably want to hide the sides of the strip. Yeah, the strip is 12 millimeters wide. That's correct. Well, I can show you again. Yeah. And that is basically because they take a cob LED strip and make addressable zones and have the chips on the side here, basically. Now, do you want to know the real secret? Because when I ordered this guy, I also ordered something else. And we'll take a look at that next. Let me move this to the side. One of the things that's always been an issue is that LED strip or addressable LED strip cannot be used for primary lighting, because the quality of the white light, even if you have RGBW or WWA or whatever, is not good enough, right? So the CRI or the RA value of the LEDs is too low. It's like CRI 70, and that will basically make your hands and things look horrible. And you can't use that in the kitchen, or I wouldn't use it for any primary lighting unless the CRI value is above 90. And for now, the only choice for that has been analog strip. So nothing addressable, just have an analog controller, which I also have designs for, and use that. But then I bought this. It's from the same manufacturer, and it's a cob LED strip, again, 24 volts, again, but now it has 420 chips per meter, and it says it's CRI 90. And I happen to have a spectrometer, and I've tested it, and it actually is. It's actually CRI 91 or 92, and it has a decent R9 value, if that means anything to anyone. All right, I can actually let me try and show you that before I hook this up. Where did I put this? Well, I'll just run the program. Okay, never mind. So let me share that program with you guys. Huh. I'm not sure that's fully working. Anyway, let's load up WS28 SK6812 RGBW, right? So that is RGBW SK6812, and we get a nice. Let me make this bigger. We get a nice graph over here, and it says 84 CRI, and you'd think, oh, that's actually pretty decent. But then let's dive into that, because then we can't see these. Damn it. Hold on. Nope. Still nope. But then if we take a look at the spectrum of the light, like so, we see that, yeah, we can see my mouse. We can see that the R values are all kind of all over the place, and the most important value, or the hardest one to reproduce, R9, is actually quite low. And this is already RGBW, so with a dedicated white LED. Now let me show you. Let's see. Do we have something else here which is interesting? All right. This is another type of RGBW LED. It's not showing you, and that is even worse. But it's not showing you that. Did my music end? Oh, this what? This thing didn't have music. I've re-enabled it. Why can't I select this window? There we go. So this is another RGB. This is a Ghoulie RGB puck, and it actually has a minus value for R9. So it's so far off in the spectrum, it's just, it doesn't even know what to do with it anymore. So there's another thing that is also interesting to look at. That is not this one, this one. Let me see if I can show you that. So this is TCLI, that is a different measurement standard than CRI, but the basic problem is this. You see what red is supposed to kind of look like, and then this is what it is. Look, what the light source is displaying it as. And you can see that all these colors are basically off from what they should be. So it compares what it knows that color should look like, how it looks like with that light shine upon it, or shining on it. And well, it's all off, and it's bad. It's bad. So now let's load up the RGB strip, or the cob LED strip we're looking at in a minute. I think it's this one, yes. And now we see that that's looking a whole lot better. We see that all the normal values are pretty high in the 90s, and just R9 is a bit lower, but that's actually pretty normal for CRI 90 rated strip. But if we compare this to the RGBW from SK6812, this is miles better, and it matches the colors we're supposed to be seeing. Jesus. A whole lot better than any of the other addressable LEDs we've had before. Oh, we're discussing the LED stuffs. Oh, I think the cob LED strip is actually 720 packages, or rather, it's a flip-on chip board, so it doesn't really have much of a package around it. But yeah, there's 720 individual LEDs on that strip, not combined per 3, basically. I have some tests of WWA before Juke Boy. And basically the CRI is about the same as the RGBW variant, so it wasn't great. But for this stuff, it is actually quite good. Or quite good. It is a decent CRI 90. And it even says 93 CRI, but that's because how it's calculated and things like that. But this is usable for primary lighting. Now, it's not the best out there, so let me, for instance, load a 3000K Oxma strip. Okay. So that is 97 CRI, and then if you look at this, you can understand the difference. So this is a CRI 95 Oxma strip, also in 3000K. And this is what a high-quality, great CRI strip does. It has high values in all of the spectrum. So, yes, it's not the ultimate quality LED strip yet, but instead of horrible CRI 70, it's now pretty decent CRI 90. And no, it's not the best out there you can get, but normal situations don't really need that either. So, for what it is, it's actually quite good. And I would say this can be used for primary lighting. Now, there is an issue with it. So don't go out and hit that buy button yet. Let me, I'll just leave some on the strip. There is an issue with it. It's not even that expensive. It's 24 volts, so I don't have to change anything. But this might already give it away. So let me lower the brightness a little bit. Lower this. And let's do this really, let's do rainbow, because that will show you exactly what I mean. So if you look at the strip, it has larger segments. You can't look at the strip because it's too dark. If you look at this strip, it has larger segments. So a segment starts here and ends here, okay? And if you look at it, and I selected a pattern which is going over it closely, it actually has, within one section, it has 3 zones of LEDs. So basically what they've done, they've taken the same strip as we had before, but they don't have every red, green, and blue combined, but they have red, green, and blue in their own section. And that is exactly the problem also with this strip currently. We can't address it correctly because WLED thinks this is an RGB strip. And if I have it cycle through RGB with a rainbow pattern, it'll walk like that because this is red, this is green, and this is blue for a single zone. But it needs to be changed. And I've already talked to AirCookie and the WLED team about this to integrate this. It'll require some reprogramming of some stuff. But basically each zone has been split to RGB, but we don't want to address it like that. We want to address each of those as an individual LED. And we can do that because they are individually addressable. Right? But it needs software changes to be able to do that, and then we'll be able to do all our usual effects and things like that. We just won't have colors. It'll only be white because it's only a white strip. But then you can do segments, and you can do effects like this or any other effect, etc. And because I believe these zones are, let me measure that real quick. Each zone is 10 centimeters. So if we have a 5-meter strip, that means we have 50 zones. But each zone has RGB addressable. That means even with 24 volts, we have 150 addressable zones. And that again is the same as 30 LEDs per meter. We're still discussing terminology. But I'm really, really excited about this stuff. Because often we have to disappoint people who want to string up all kinds of LEDs in their room. Like, hey, make sure you have something else for primary lighting. But this is okay or fine to use as primary lighting. And you can have your effects and your segments and things like that. And then let's say you can make segments and effects and have it hooked up to Home Assistant. You can now do primary lighting with addressable LEDs for your living quarters or your living room or your study or whatever. And then if you want to combine it with the stuff we just looked at, you'll have the most vibrant, excellent colors and addressable warm white. And I think that is something new. That is something we didn't have before, and it exists now. You can buy it. It just doesn't work properly yet. Because if I select anything else, like Paletti, for instance, yeah, it'll do it. It'll do it. I mean, it'll do something. But it doesn't know what it's addressing, so all the effects basically don't work correctly. Rob, the CRI for SK6812 is about 70. It's quite bad. That's R9 of 10. Let me read over this discussion here. Yeah, so Cobb LED strip doesn't work with packages because there's not multiple LEDs packaged together or a framework around them like you have on normal LED strip. Basically, they place a diode directly on the Cobb material. You can kind of see it on the back here too. If I light that up, let me move this onto the screen. So you can kind of see it on the back here too. These LEDs are just directly placed on the PCB material, And then if you want to talk about a package, the cob material is the package. So if you were to peel this back, you just see bare LED chips, basically, right? Yako, there is a chance the WLED team will have it supported before HA is out. Well, actually, this is in arm's length reach, and I've actually been doing stuff for HA. Oh, okay. This week, so HA might be closer than you think if I finally follow through, but still. Do you also have an RGB value for RGB white? A CRI value? No, there is no CRI value. Basically my meter refuses to measure RGB white, and then I have to set some kind of override setting so that it measures whatever. And it doesn't know. It just is like, I don't know what this is, but this is not white light. And that's correct. So, I mean, white light is a spectrum. It's not made of one value of R, one value of B, and one... it's not made of one value of RGB. It's made... So it's not top. It's a spectrum. And so you can never make white light from RGB in that sense. So, no. Yeah, basically, I looked at Cobb CRI 90 LED strip before, but analog, and this is basically the same type of strip. But they used these side packages and LED chips, and of course a different strip material because you have to route the signals and things differently. But they basically use the same LEDs, and that's what I've been wanting them to do for years. They can make high CRI LEDs, and I just wish they put them on a WS2811 chip and use them like that. But I don't know, for some reason they wouldn't. And now they have for this cob material. And it even goes pretty bright. So if I set it to solid and then set it to white, yeah, and it's still on the roll. It's getting, okay, let's take it off the roll because it's getting warm. But it's a decent amount of light, and it's using, let's see what it's using, 60 watt. So 60 watt of light is pretty decent. And again, these are cob LEDs, so in theory, they are a bit more efficient than regular big package LEDs, basically. Oh yeah, the smell is on. But I mean, that's a decent amount of light. I mean, right? Holy sh... My studio is not dim. Oh, okay, I'm going to turn that down now. Thank you. There is some PWM there, though. Interesting. Not sure why we're seeing PWM. I guess we're not seeing it at 100%. Oh. So the PWM might actually be slightly low. Let me see if I can do a very quick measurement of that. I thought I already did. Let's see. Let's put it over here. This is a very quick, crude measurement. Don't take anything from this, but I just want to see. Lightmaster Pro. Oh no. So yeah, I use this Lightmaster Pro thing, and it says it's 95 or okay. 90 is actually pretty okay. Yeah, Okay, CCT is often correct for this measurement tool. I use a different tool for the other stuff because this isn't that great. But let's do a flicker measurement. It says the frequency is 2200. I don't know. Hold on. I'm trying to show you at the same time. There. This tool isn't that accurate, so don't. I'm not sure I'd recommend using it. 2346. Okay, let's change the intensity a little bit. $1167. That's more what I expect it to be about 1200 PW or PWM rate. So, oh yeah, okay, yeah. So this is a good measurement, I think. And so PWM 1200 hertz. That's okay-ish. That's fine. Yeah. How do I go to the other one again? Yeah, I wouldn't trust this value. It's not that great. Lux is, of course, dependent on distance. The CCT is pretty close. It's more around 3000, but I think like this, it's overwhelming the meter, as you can see. And of course, there's lots of other lights on right now, and yeah. I mean, don't trust those measurements. I use a different instrument for the other measurements, so. The CRI for RGB is non-existent. There is no CRI for RGB LED strip. Just keep that in mind. You cannot make white light spectrum with RGB. Because you have a mountain of R, a mountain of G, and a mountain of B. Right? Because it's RGB, red, green, blue. But white strip isn't mountains, it's a continuous spectrum. So you can never make white from 3 peaks. Because it's always 3 peaks, while white is a mountain, a spectrum. So forget it. Or you can make light that has a white color. Okay? But that is different than having white light. White light is something of its own. It's a how do you explain that? So you can have something that has a white color light, but you have to treat it like it's red, green, or it's whatever other color. But white light, true white light, is a whole different spectrum. So the difference is from looking at something and saying this is white, that can be. And the difference is that what you see if the light shines on it, if that light is white or not. Because if it shines on it, it reflects back the spectrum that was shown upon it. And if that is a very limited spectrum, it's only going to reflect a very limited spectrum. But if you shine true white light, it is a very broad spectrum, so you'll see the object as it's supposed to be. Color rendering, yeah, exactly. Would you consider the minimum CRI for video shooting? So this is OK CRI 90. It's a whole lot better than anything we've had before. But for video shooting, I'd recommend the Oxmer or the Color Diode CRI 95. That is literally what I'm using myself. So my 2 top bars here, which shine on the desk, those are Oxmer. And my other primary lights, those are all Color Diode, and they're all the 4300 Kelvin variety CRI 95. And I think that I look pretty natural while there's good colors, and this is still on. So, yeah, but I do spectrometer measurements with my spectrometer, and those are true CRI 95. So, yeah. Yeah, so that's still the domain of analog LED strip. But for digital, so if you want to do, let's put it to red. Here you can also see this is set to red. Let me show you the interface. So that is currently the problem with this LED strip, which needs software changes. Oh, there. This is the strip set to red. So now, let me find the. Yeah, this is the first segment after this cut mark over here. Don't think we're in focus. There, a little bit less bright. There we go. So we have this cut mark, and now WLED is set to red. Let's set it to green. That's the next one in this segment. And let's set it to blue. That is the next one in this segment. And then set it to red again, and then it continues on, but it starts over here again too. So the driver in WLED needs to change, and it needs to address each of these as an individual pixel. And once that is done, well, everything else in WLED will function as it does normally. And then we can use addressable LED strip for primary lighting in our living spaces. Yes, James, that is correct. You can use the fifth output if you want to. Was that a question from someone? Access to everyone? Correct. These cob LED strips do not have weatherproofing, and the reason for that, even if you think, but everything looks protected, well, no, not completely. Of course, these chips aren't protected, and the cob material actually, it actually, oh, in this strip it doesn't. No, it actually breaks between the solder. So these are all 0.5 meter pieces, and the cob material breaks per LED section, basically, right? But it's just a matter of time, because I also have this stuff which I want to use in one of my upcoming projects, and this is the same type of stuff. Can I get it out of here? Not easily. But this is the same type of cob LED strip, but now it's housed in a silicone sleeve, so now it can actually be used outside, and it actually has tape on the back, so that's no problem mounting it somewhere either. So once they release this kind of stuff and the other LED strip, once it gets used enough, they'll start making IP65 and 67 variants too, like this stuff. And, well, this would look excellent and is fully weatherproofed. So, at some point, that will come. This is an analog variety, but if they can do it for this stuff, well, they can do it for this stuff too. I mean, right? Yeah, you could use white and then monochrome effects. I can show you that. So let's set it to white, and then do an effect like oscillate. No, like Pacifica. No, that still uses different colors. Color 1. There we go. But now we only have 50 zones. Paletti? No, Paletti doesn't do anything because there's not multiple colors. Popcorn, I guess. Railway. No. Rain. Rainbow Runner. No, you can't do rainbow. Saw? Yeah, it's very limited which effects will work. Irritarto, yes. DGS, I'm waiting on my first dick quads coming. Will using the dick quad for a really slow fade like you have in the background eliminate flicker? What are we talking about, DGS? You mean flicker on camera or... So Carlos Arida asks which voltage regulator is recommended after the dick quad getting low voltage on my power injection runs. You'll have to explain that to me because you're likely using too thin wire. Sure, access to everyone. The buck converter 24 volt transport voltage and then 5 volt LED setup is still fine. I mean, but there's now more options coming to the market which are actually different than before. And that's what is exciting. Especially this CRI 90 stuff. Now I don't have to say you can't really use LEDs for primary lighting or addressable LEDs. No, you can with this stuff. We still need support, but it'll get there at some point. I'm gonna drink a Coke. Great fish tank light. And all the links are in the description, Turtle Plates. Turtle Plates Tech Turtle. Nice. Carlos, what do you have in regards to wire size going into the dick quad? I currently get flicker, maybe it's PWM, when the colors are changing during a very slow fade on either 2812B or SK6812. Well, that's an interesting subject, DGS. Are you running those LEDs full power or not? Because a addressable RGB LED in a WS28 whatever protocol is 8-bit per color. So 24 bits in total. That means red can be 0 to 255. Okay? So if you're doing fading and set to full brightness, it can fade between 255 and 0. So that is 255 steps. But now let's say, yeah, but that's too bright. I only want 30% or 50, okay, that's 50% brightness. Max. Okay. Okay. So now you're fading between 0 and 182. But if you make each fade last 1 second, it now has 128 steps between 0 and your set max brightness instead of 255. So if you have it do that in the same time, it'll have less steps and thus become choppier. So if you only run your LEDs at like 15%, it only has 0 to 32 and back again, so 32 steps instead of 255. And if you set it to fade over a time period of 5 seconds, well, 255 steps in 5 seconds might look okay, but 32 steps in 5 seconds, well, you'll definitely see those steps. So, are you maybe running your LEDs very dimmed down? Because with the current type of addressable LEDs and stuff like that, that will automatically affect the amount of steps the dimming or the fading can basically do. Carlos, that sounds okay. How long is that run you're seeing the low voltage on? Yeah, joining the Discord for everyone here if you have questions which didn't get answered here or need a bit more technical details, etc. The Discord is the perfect place for that. So I think I'm going to go on for maybe another 5 to 10 minutes. And then we're going to call it quits for today. But yeah, you got a lot of secrets. And I am so excited about these new strips. It's just excellent stuff. Can I actually do something illegal? This is the warm white one. This is the RGB one. It works. What is the maximum power draw we're going to see? Am I going to blow the fuse? I don't know. We'll see. Let's see. Solid. White. Okay, let's go to 50% power. Okay, 50% power is 56 watts. Let's go to 100%. Ugh. Oh, okay. That's only 96 watts. Interesting. Huh. Oh, I know why. I don't have all the LEDs configured. Hold on. So let's make it 300. Say it has 300. Ah, there we go. Full power. 112.9 watts. Okay, so stringing these two behind each other is giving massive voltage limiting, because I can get the RGB strip alone to draw 115 watts, let alone with the other strip attached to. Anyway, that's just a little bit of fun. How did I find these new strips, says Rob Starkey. I regularly order new strips that appear online as testing samples. Most of the time, you're not going to see anything from that. But sometimes I find something really good, like this stuff, and then I show it to you guys. $40 to 60 feet. Wow, that's a long cable. Cool, DJS. Well, hopefully you can figure it out with that. You still have 255 steps, but if you limit brightness, the amount of steps also decreases. That's basically the issue. Access to Everyone says, I have 1100 lights on the front of my house, 550 one channel and 550 second channel reversed on a day quad. I get an intermittent flash flicker on the reversed segment or channel. Huh. Are those 3-wire cables, and did you flip those little dip switches there, Access to Everyone? Anis Kadri asks, do signal repeaters enhancers help with voltage drop? No. If they, like a data booster, if you don't hook up additional power, it'll help with the data signal, but it won't help with power. But my data boosters also have a spot to hook up extra power injection, and then they do. Have you ever used 144 LED per meter LED strip of WS2812B? I have, but I generally like to use WS2815 for that, or SK6812. So my LED load testing bars, those are all, I guess I can show you, those are all, you can't see, okay, yeah, no, almost. Come on, camera. Okay, I'll show you on the top cam. So these are all 144 LEDs per meter, because that allows me to generate a lot of load, especially with RGBW like this. right? But generally, I'd move to 12 volt for that. DJS says, it's starting to make sense. Thank you for the help. Thank you for the £2. That is very much appreciated. Do you have a video that shows how to set up your WLED config? Yes. If you go to my website and you go, let's go back. So you go to Quinled.info, you go to digitally addressable LEDs, and you go scroll all the way down, and there's a WLED 0.12. What do I configure? You can look in that article. It has a few indexes. Or you can look at these videos, especially this WLED tutorial 2022. We'll go through how to hook up the board and how to configure everything, etc. You're making a dodecahedron. Whoa, dodecahedron? Yeah, I guess. Dodecahedron. That's it. With 2812B, 144 LEDs a meter, and it's 6 meters. It will be 60 amps. Is it RGBW? How many LEDs is that? Let me calculate. I don't think it'll be that. 154 times 6. That's 864 LEDs. If we look at the LED power sheet, so we go back to the addressable LED section, and we go to the digital LED power usage sheet, and we go to the 5 volt sheet, and there we look at WS2812B, and then let's take 100% white, which is 65 watt. Okay, but that's 65 watt. Let's divide that by 300 times 864, I believe we just calculated. That is 187 watt. Let's divide that by 5, because it's 5 volt. That is 37.4 amps if all the LEDs are set to 100% white. We generally don't do that, so let's divide that by half. And that is 18.72 watts is the nominal amps I would calculate with that setup will run there, Ducky Dev. At full max power for single colors or effects. But you can check in the power sheet. I normally calculate with 50% white, and this is for 300 LEDs. But as you can see, even Police All, Loading Orange, or Rainbow doesn't use above 25 watts. So even this 33 watt figure is already a bit high, because a single color won't do that either. I hope that makes sense. Oh, 600 LEDs in total. Well, then you can just double these numbers, and then you have the amount of LEDs and the expected power usage. So I definitely take a look at the digitally adjustable power sheet, which you can find in the power-related section of the digitally adjustable LED section, and calculate using that, because that can give you a lot more realistic values than 60 amps or whatever. I saw your LED strip recommendation video. Do you have any recommendations for pixel strands like outside Christmas lights? Yes. I actually have an article, which I don't see right now. Oh, right, it's in my buying guide. There is a 12-volt WS2811 bullet waterproof pixel shopping guide, and that'll guide you through buying the LEDs, buying the connectors, and buying all the other stuff like extension cables and Y-splitter or T-splits. The images here are still wrong. I need to adjust those because they're for different types of connectors, and I didn't realize when putting them up. But the links are correct, and they all go to the X-Connect system. And if you get the X-Connect pixels and the X-Connect extension cables and the X-Connect pigtails and the X-Connect T-Connects, you can build everything without having to solder a single thing. So that's over here. But again, the photos on the webpage are wrong. I still need to correct those. I have never seen an RGBW bullet there, Tech Turtle. I have seen WWA bullets, but those are also only 5 volts. And that's okay there, Brian. It's actually not been up for that long yet, so. Can you update your WLED to 13.3? Yeah, I'd say so. Sure. On my boards, for sure, yeah. Access to everyone, I wouldn't know right now. Maybe come to the Discord and we can take a look, but... Oh, I wouldn't. That's a bit odd. Did you have the resistor switches flipped to the type of cabling you're using? No problem. It's okay to bring it up there, access to everyone. That's okay. I do not know of a permatrack alternative in Europe right now. Sorry. Oh, wow. You're using a lot of SK6812 there. Cool. Well, as I said, I am starting to round this off. If people still have questions, please come to the Discord server. There's smart people there all day long, and we try to answer all the questions we can. And often people stick around because they also become smart people about LEDs and knowledgeable and things like that. So yeah. Oh, access to everyone, $10. Thank you very much. Let me go to the face. Thank you. That's very much appreciated. But I need to round this off. We've been streaming for about 2.5 hours already. And, well, I do want to thank everyone for being here. I am really, really excited about these two new strip variants. I will try and make a dedicated video about it sometime soon. We're also likely going to be doing HAHA stuff for real. And I've been working on the DIY backup project and... lots of stuff going on, but LED season will be winding down a little bit, so I get time for other projects too. And of course, Project Energy is coming up. Oh man, I'm doing too much stuff. But that was already obvious, I think. So, the face... No, it's on a dummy battery, Philip. It's, yeah, Project Energy, yes. So yeah, I got a dummy battery for this thing now. It's in a Quinbox, I think, which I haven't released yet. So, anyway, thank you all for being here and participating. I always love the chats and talking with you guys. So, yeah, I'll see you guys in the next video, in the comments, or maybe on Discord. Bye-bye. Wait, stop the press. John Kuster came in with $19.99. Thank you so much. That is awesome. Thank you very much. But I really was going, so sorry. Thank you for the donation, John. That's very much appreciated. What is going on? I'm still here. Rob Keen, thank you so much for the donation. $5. That is awesome. You're never going to let me leave, are you guys? Oh, thanks, guys. Thank you. I knew you were going to do that, Philip. Thank you.